Hello everyone. In this video, we're going to be solving a nice cubic equation. Now, this problem is pretty interesting because this came up as a homework problem that was given to a college student, and the idea was to graph this. But to be able to graph it, as you know, you need to find the x-intercept, the y-intercept, the maxima, minima, so on and so forth, right? But when you try to find the x-intercepts or the solutions or roots, you run into problems. So that's what I'm going to demonstrate in this video. Let's go ahead and see how we can solve this problem. And do you think this should have been assigned as a homework problem to a group of students who do not know the cubic formula, who has no idea what the cubic formula looks like? All right, let's go ahead and explore. We have x cubed minus 3x squared equals 2. So here's what I'd like to say. If these two terms were switched, suppose we had 3x squared minus x cubed equals 2, actually things would be awesome. You know why? Because x equals 1 would be a solution. You get to see that, right? If x equals 1, this works, so it's a solution. Unfortunately, that's not what we have. So we have to find a number that satisfies the opposite. How is that possible? Let's go ahead and find out. So to be able to solve this problem, I'm going to use the cubic formula. So I think this is going to be a good representation or demonstration. But to be able to do that, first we need to get rid of x squared. And to do that, we're going to replace x with something else. X is going to be replaced with, and let's just go ahead and use y, because why not, right? Y. Now, here's what I need to do. First of all, take a look at this sign. It's minus sign. So I'm going to change it, negate it, which is going to make it a plus sign. And then I'll take this number and divide it by the highest power, which is the degree of the polynomial. It's a cubic equation, so it's a third degree, so it's 3. 3 divided by 3 is equal to 1, so that's the number that I need to use. So if you ever forget what is used to substitute, this is how you find it. So let's go ahead and do this. This is fun. Replace x with y plus 1 to the third power minus 3 times y plus 1 to the second power equals 2. Now we're going to go on and expand it. Hopefully from the cubic formula, you know that this is y cubed plus 3y squared plus 3y plus 1. And then if you consider the fact that this is y squared plus y plus 1, y squared plus 2y plus 1, and multiply that by negative 3, you're going to get negative 3y squared, negative 6y minus 3, and then that is equal to 2. Notice that this operation, this substitution, allows us to get rid of y squared, which is really, really cool. Now 3y minus 6y is equal to 3y, but with a minus sign, so it's going to be y cubed minus 3y. And this 1 minus 3 is actually negative 2. So you can go ahead and add 2 to both sides and turn this into 4. So far, so good. Again, we kind of run into a really weird situation because if you think about it, if you had a plus sign, y would be 1. But we don't have a plus sign. Too bad. But you see, something is going on here. Let's go ahead and find out. So in this equation, we are going to use an identity. Obviously, that's how the cubic formula works. And here's the identity. A plus b cubed, a plus b quantity cubed. If you subtract from it, this expression 3ab times a plus b, guess what that gives you? The first term and the last term. The two in the middle, they cancel out from binomial theorem. And remember, we just used it here as well for the cubic. It'll be a cubed plus b cubed. So that's something that you need to know. And even if you forget, you can always come up with it. Really easily derive it, okay? Now, how is that helpful, right? Well, if you set this equal to y, and then you get something like y cubed minus 3aby equals a cubed plus b cubed. Now, if you compare this, obviously, this equation, one of the solutions to this equation is y equals a plus b. We know that, right? Y equals a plus b is a solution. But guess what? This equation is pretty much the same thing. But which ab values allow us to turn this equation into this one, right? That's the question, the $1,000,000 question. Actually, it's not that expensive. So, but here's what happens. 3ab needs to equal 3, which means ab is equal to 1, okay? And the constant term on the right-hand side is 4, which means this is equal to 4. So a cubed plus b cubed is equal to 4. Awesome, right? So we're going to go ahead and solve this system. And there's so many ways you can solve it. One way to do it is cube both sides here. That gives you a cubed, b cubed equals 1. And from here, you can isolate b cubed and write it as 1 over a cubed. And then you can actually go ahead and substitute that here and just solve it that way. Another method is, which is something that I usually like, isolate b cubed from here and write it as 4 minus a cubed. And then go ahead and use it in the other equation, which is this one, right? So let's go ahead and do that. Replace b cubed with 4 minus a cubed, and this product is equal to 1. So let's go ahead and solve for a cubed. But how do you solve for a cubed? Is that going to give us an hexic or hectic equation? Not really, because if you set a cubed equal to c, you can realize that this is indeed a quadratic equation. Look, c times 4 minus c is equal to 1. And then we get 4c minus c squared equals 1. Hopefully you can see what I see. C squared minus 4c plus 1 equals 0. And guess what? This is a quadratic equation. Very, very easy to solve. Again, you can use the quadratic formula. If you don't like formulas, you can go ahead and subtract 1 from both sides and then add the magical number, which is completing the square. Half of 4 is 2. 2 squared is 4. So you're supposed to add 4 to both sides. If you do, you get this. And the left-hand side becomes c minus 2 quantity squared. And from here, we get the values of c. C minus 2 can be square root of 3, or c minus 2 can be negative square root of 3. Because there are two numbers whose square equals 3, right? You know that hopefully. So from here, c becomes 2 plus root 3, or 2 minus root 3. Of course, there are two values of c because it's quadratic. And where does c come from? C is equal to a cubed, but it could also be b cubed, which means one of them is a cubed, the other one is b cubed. I'm talking about the solution. So if this is a cubed, then I get this equation, which means a is equal to the cube root of 2 plus root 3. And from here, b becomes, because we're just going to assume that b cubed is equal to this, then b is going to become the cube root of 2 minus root 3. Wait a minute, are you solving for a and b? Well, kind of, because we are looking for x, which means we're looking for y, because we have to back substitute, and y is equal to a plus b. So if I find a and b, then I found y, which I did. So y is equal to a plus b, which is the cube root of 2 plus root 3 plus the cube root of 2 minus root 3. And don't you love that expression? It's beautiful, right? Very, very cubic and very radical. Now, what are we going to do with this, right? Y, we have to go back and back substitute. X is equal to y plus 1, which means x is 1 more than y. So x is going to be this number plus 1. So let's go ahead and write this number again. And we're just going to add 1 at the end, and that'll give us the x value. But wait a minute, this is a cubic equation, so aren't there 3 solutions? Yes, one of the solutions is real, the others are complex. How do I know that? Because I graphed it, and I solved this equation, the other solution. Now, suppose the other 2 solutions were real too, would you want to find them? I don't think so. And even if in the complex case, how do you solve them? You kind of need to reduce the cubic, but trust me, that's going to be super duper painful. All right, let's go ahead and take a look at some stuff which is going to show us the solution from alpha and the graph of this equation. First of all, we're going to be looking at the graph. As you can see, there's only one solution because there's only one intersection point. And ta-da! Here's the real solution like we found. One is at the end, doesn't matter. And these are the complex solutions. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe. Take care. Don't forget to check out SyberMath, the Shorts channel, and aplusbi. And bye-bye.